Lesson 21 is on simple harmonic motion. Now this is just kind of a continuation of the skills that you learn in graphing sine and cosine. There's a lot of things that vibrate, oscillate, rotate, or move with what we call a wave-like motion. So this would be using a sinusoidal function, using a sine function. A point is said to be in simple harmonic motion if its distance d from the origin at time t is given by either d equals a times sine of bt or d equals a times cosine of bt. So you could have t or x, it doesn't matter. So the motion would then have an amplitude. So if you think about your last lesson, it's the number out front, so an amplitude of a period, so usually a period is 2 pi, but this one involves some kind of horizontal shrink, right? So it's going to be 2 pi over b, and a frequency, which is always 1 over the period, so the reciprocal of the period, which would be b over 2 pi. So the frequency is the number of cycles completed in one time period, like in 1 second. So maybe you do 2 full sine curves in 1 second, so that would be the period. Or the frequency, sorry. So suppose that a weight hanging from a spring is set into motion by an upward push. It takes 5 seconds for it to complete 1 cycle of moving from its equilibrium position to 8 centimeters above, then dropping to 8 centimeters below, and finally returning to its equilibrium. So the equilibrium is this x-axis, basically. And we're going to go up, and then we're going to go 8 centimeters below. So we have 8 here, and we have negative 8 down there. And it completes this in 5 seconds. Okay, so we want to sketch a graph of the function, so we have the graph, and then we want to come up with the equations. That's part B. So find a sinusoidal function to represent the motion of the moving weight. So if we have this kind of graph, we know that the period is 5, right? Well, that means that 2 pi over b has to equal 5. So we solve for b. So the easiest way to do this is to multiply the b over and then divide by 5. Okay, so that's going to be our b value. Now our a is the amplitude. So it's easy to see in this picture that the amplitude is 8. And we can tell that it's a sine function, not a cosine function, since it starts right here on the x and y axis. Now I could do a cosine function. So sinusoidal functions can be either sine or cosine. But since this one does start along the x and y axis at the origin, we just use sine. Okay, but we could do some kind of shift and make it a cosine function. Okay, so that means that our equation is going to be d equals a, which is 8, sine of bt. So we're going to have b is 2 pi over 5 t. Now on Math Excel or anything that you do with these types of things, I'm going to guess that we would have, instead of d and t, I would guess that they would have you put an x and y. So I'm going to go ahead and do that. So it would look like that. So this would be the x-axis and the y-axis. Okay, so we have y equals 8 times sine of 2 pi over 5x. So that's going to be our equation. And it says use the function from part B to predict the weight of the height of the weight after 3 seconds. Okay, so that's our time. So that's going to be our x value. So we're saying in 3 seconds. So we're going to have y equals 8 times sine of 2 pi over 5 times 3. Okay, so we have 8 sine of 6 pi over 5. Now this is not a unit circle value, so I will allow you to use your calculator on this. So go ahead and get your calculator out. And just make sure that you're in radian modes like usual. And we're going to have 8 sine of 6 pi over 5. And when we do that, we end up getting a negative number. We have negative 4.702. Okay? And it says that this was in centimeters. So what this means is that we're below, right? So we had the graph like this, and at 5 we crossed. So that means at 2.5 we were right here. So it makes sense that after 3 seconds we would be somewhere below, but not quite to negative 8 yet, right? All right. And then in the first 5 seconds, when will the height of the weight be 6 centimeters below the equilibrium position? So we want to find when y is equal to -6. So use your graphing calculator to assist you. Okay, and this time it says, hint, there are 2 answers. Well, let's think about it. We have this graph drawn. And when will it be at a height of -6? It would be somewhere around here and somewhere around here, right? There's going to be 2 locations where that's true. Okay, so you can do this without a calculator, but it's a little bit tricky because you would have -6 equals 8 sine of 2 pi over 5x, and you would divide by the 8, so you'd have -3/4 equals sine of 2 pi over 5x, and you would end up doing inverse sine, right, of the -3/4. But that would only give you one answer. So on your calculator is only going to give you one answer for the inverse sine, and we'll talk about that throughout this semester. So what I want you to do right now is I want you to graph it. All right, so as we graph it, so let me go down to my little graphing calculator. I want you to graph 2 functions. First, make sure I'm in radian mode. Okay, so y equals, I'm going to graph -6, and I'm also going to graph the 8 sine of 2 pi over 5. So second pi over 5, and then x. So you could put the x up here with the 2 pi, but if you just kind of put it to the side, it will do the order of operations. So we'll do the 2 pi divided by 5, it will take that result and times 5. Okay, but if you're not sure, you can always put extra parentheses. A lot of people aren't very sure at this point in pre-calc. So you could always do an extra parenthesis like that. Okay, and we said in the first 5 seconds. So for my window, I'm going to go ahead and put it from 0 to 5 for my x values because that's using the first 5 seconds. And our y min and y max, you could do -8 to 8. -10 to 10 is fine though. Okay, so we're going to go ahead and graph it. Oops, what happened here? Oh, that's my first one. That's the -6. Sometimes when you get a straight line, if you've made a mistake with your sine and cosine, it's because you aren't in radian mode. So at first I thought I had done that. So basically I want to find this value and I want to find this value, okay? And it's saying when, right? So it's asking for the time. So I'm going to do second trace, and I'm going to find the intersect, okay? And in order to find the intersect, all you do is it goes along the first curve, you get right on top of where you think it is, and then the second curve, if you do right and left again, you're along that second curve now, and get right where you think it is. So a lot of times you just hit enter 3 times. Okay, so the first one is 3.175. Okay, so we're going to write that down. So we have x equals 3.175, and again, this is in seconds. And then we find the other one. So we do the same process. So we do second, trace, intersect. And now we go along that first curve again. So the y1. Hit enter. Second curve, again, if you do right and left, you'd be along that second curve now. Hit enter, enter. And so we get 4.325. All right, and if you actually plug those into your original equation as your x value, you would get a y value of -6. So you can check, and it does work. All right, so that's how you would do these like application problems with sinusoidal functions. So it's really not that bad. All right, so the next one. So it says Emerson's fishing bobber oscillates in a simple harmonic motion from the waves in the lake. So his bobber moves a total of 1.5 inches from its high point to its low point and returns to its high point every 3 seconds. Okay, so this is a little bit tricky. The way they're wording this is a little strange. So now we're starting at the high point. Okay, so we're starting right here. And it's going to go from a high point to the low point and go back to the high point in a time of 3 seconds. Okay, and it's saying that this total distance is 1.5. Okay, so if you take 1.5 and you divide by 2, you would get 0.75. So that means that this height right here is 0.75, and this one down here is -0.75, okay? So write an equation modeling the motion of the bobber. So this time we see that we're starting along the high part. We're not starting at the origin anymore. So it would be appropriate to use cosine, okay? And sometimes you might have ones that start at the bottom, and that's when I would use negative cosine, okay? So we're starting at the top here. So we're going to have y equals, and we're going to use cosine. The amplitude is 0.75, and we're going to have cosine, and then we need our b value, so we need b times t, or b times x. So that's when we always think about what the period is. So the period is a total of 3 seconds. So the period is always 2 pi over b. So that allows us to find what our b value is. So if I multiply the b over and then divide by 3, I get b is equal to 2 pi over 3. So I'm going to have 2 pi over 3, and then I'll use x instead of t. Oh, I guess I do say at time t equals 0, so maybe I should use t in this case. Okay, so that would be the equation. And you can ask lots of things about this equation. I could say, when does the bobber reach a height of 0, right? When is it on its equilibrium position? So you can ask lots of questions. All right, so a Ferris wheel that is 60 feet in diameter. These ones are the ones that are always tricky for my students, so I decided I should do one of these. So we have 60 feet in diameter. Makes a revolution every 80 seconds. So we're going around every 80 seconds. If the center of the wheel is 35 feet above ground, okay, this is the part that a lot of people don't understand. So we're 35 feet above ground. Okay, you don't get on the Ferris wheel at the bottom. A lot of times when you get on a Ferris wheel, you kind of walk up a step. Okay, so this distance right here is going to be 35 feet. You don't want the Ferris wheel to like scrape against the ground, right? Okay, how long does it take for a rider who starts his journey at the bottom of the wheel to reach a height of 50 feet? Okay, so it's kind of hard to visualize. But we know that this distance right here is 30, right? Because the diameter was 60. So we're starting down here. Okay? So we're going to say at 0 feet. And we're going up, 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 up. So after 40 seconds, we're going to be at a certain height. So after 40 seconds, we're going to be at our 60 plus 5, right? So we're going to be way up here. So we're going to be at 65. And then after 80 seconds, we're going to be back at 5, actually. So maybe I shouldn't start it at 0, I should start it at 5. Because here's where you are, right? So we're starting at, not at 0, 0, but we're starting at 5 feet. We're already 5 feet off the ground. So at 80, we're back at 5. So we're going up and then down. Okay, so it's like a sinusoidal function. Okay. So this one involves some kind of vertical shift as well. So it's going to look like y equals a sine of bt, but then we're still going to have some kind of plus number. Okay, so you can say plus c, whatever. Okay, so our c, how much we're shifting, is the 5, right? This is our vertical shift. All right, and it's a sine function. It starts here, it goes up, and then it comes back down. Well, actually, a sine function does this. So we have a portion of it, but we don't have all of it, right? Because we didn't go below the axis. So this one would actually be better to use a cosine function. And here's going to be our equilibrium point. Okay, but it's kind of tricky because it's actually a negative cosine function. So you could start it right here and use just a regular cosine function, or you can start it here and use a negative cosine function. So there's going to be a couple different equations that you could write. All right, so what I'm going to do, let's say I started at the first point there. Okay, it is the opposite. It's been flipped from something like this, right? So it involves a negative cosine, okay, because it's going the opposite direction. Okay, so I'm going to have y equals, and I'm going to have a negative, and then I'm going to have my cosine function, and I'm going to have my bx, and then I'm going to have plus something. Okay, so my amplitude, if you check, the distance between 60 and 65 is 60. So my amplitude is right here. My amplitude is 30. So I'm going to have 30 is equal to 2 pi, or not 30 equals 2 pi over b. 30 is equal to my amplitude, my a. And my b value involves the period. Well, when does it get back to that same starting position, right? The same location was right here, right? And then it starts that wave over. So that was a total of 80 units. So I'm going to have 80 is equal to my period, and the period is always that 2 pi over b. So I'm going to have 80b equals 2 pi. In other words, 2 pi over 80 is equal to b, and we reduce that, we end up getting pi over 40. So that's going to be my b part. So I'm going to have my 30 here, and I'm going to have pi over 40x. Oops, I wrote 400x. Okay, so let's think about it. So if I have this, that means I have the negative cosine value, which would start down here. It's going to be a total of 30, right, for the amplitude, and it's going to go up and it's going to go down. So this one is almost like that, except it's been shifted. Okay, so I don't start at negative 30. I start much higher, right? So I want to know how much I've shifted from that negative 30. That's what the one that I have right now would look like, okay? So I have shifted up how much? I've shifted up 35 units. So the last thing I'm going to do is plus 35. Okay, so that's one way that we could write this, and you can verify with your calculator. You can plug it in and see if that's right. But I don't think it was necessarily the easiest way of writing it. Okay, so I want to consider another way of writing it, because these sinusoidal functions, I mean, since we have a certain period, right, they repeat themselves often. Okay, so if you can find a different starting point, sometimes it makes it a lot easier. So let's consider if we didn't start at the first point there, and what if we had started instead right here? Does it make sense why we would start there? Sure, because that's what a cosine curve looks like, right? It has that little like U shape for a cosine curve, and usually it starts along the axis like that. So usually that's what cosine looks like. Okay, so if we can make that our starting point, our equation might be a little bit easier to come up with, because that negative and adding the vertical shift, that can be a little bit difficult. So we're going to consider this as my starting point. And what helps sometimes is if you draw a new axis, okay? And then you just think about how much you shifted to go to that axis. All right, so what I would do then is I would say, okay, well, this looks like a cosine curve. With this cosine curve, I have a certain amplitude, right? And that amplitude is still that same distance that we talked about. It's still 30. And I have a certain period, and that period is still the 80, so we still get the b equals pi over 40. So all of this information is still true. But that starting position has shifted over. Okay, so the starting position, this new axis, how much has it moved from this other axis? Well, it's moved over 40, right? And it's moved up a total of, if you look at it, we were at 5, and then this was an additional 30. So we were at a 35, right? So we moved up 35. So when we do a cosine function, what we would do is we wouldn't have a negative anymore, but we would say that we have 30 for our amplitude, and we have cosine, but we have both a b value and a shift, like a horizontal shift involved. So I would write it as pi over 40, and then I would say x, and I'm moving to the right 35, or not 35, 40. So I would do x minus 40, and then up 35. Okay, so you could write it like that, and you could even simplify by multiplying the pi over 40 in. So just know that there are lots of different ways to write these. So if you get stuck, it's not a big deal. Just come in and ask some questions, right? I'm distributing here, and I can help you out with it. Okay, and then once you have the equation, you can ask lots of questions about those equations. So it could look like this, or it could look like this. So I could ask, when are you at a height of whatever? And I think I did ask a question like that. It says, when will you reach a height of 50 feet? So using either equation, so let's say I go ahead and graph. And I'll graph that first one, let's say. Oops, I don't know why it's not working here. Do a new one. I'll just use a different calculator. All right, so if I go on here and I do, let's see, -30 cosine of pi over 40x, I'm going to do pi x over 40. Then I do plus 35. Okay, I know looking at my x and y values here, I want to go from 0 to 65 at least. So I'm going to do 0 to 70 for my window, for my y values. And then my x values, if you kind of check those out, I go from a time of 0 to at least 80. So I'll do 100. So I hit graph, and it looks like the one that I just sketched, right? So you can always check by sketching it. And since I went to 100, you can kind of see it starting over again. And it says, when do I reach a height of 50 feet? So under my y equals for y2, so going down here, I'm going to put 50 in. And then when I hit graph, you see this go across. Okay, so it's going to hit it multiple times. If you kept going around and around and around indefinitely, right, you would be at a height of 50 feet an infinite number of times. So let's find these first two. So I'm going to do second trace intersect. And I go along there. And the intersect, as long as you're right there on top of it, right, enter, you can enter again, enter. So it says at 26.6 repeating, and then also over here, at 53.3 repeating. Okay, so we had at x equals 26.6 repeating, and x equals, or t equals, I guess, I'm bad about that, I use x's and t's, 53.3 repeating, and this is in seconds. Okay, now did it ask for all the different locations? I don't know, let's see. So it says, how long does it take a rider to reach a height of 50 feet? So I would think when you say how long would it take for them to reach a height, I would probably use that first value. Now if it said how many, I don't know, how many times is the rider at 50 feet? I mean, it would be an infinite number of times if you kept going, but you could write 26.6 repeating seconds and then plus, like you could write out all of the answers. Let me write it up here. So 26.6 repeating plus, and it repeats every 80 seconds, so it'd be plus 80k, meaning for every single integer k, you would keep repeating. So you could have 26.6 repeating, or you could have 106.6 repeating, or add 160, add 240, and so on. So that's kind of confusing, but we won't ask any of those questions yet on your homework for sure. All right, I think that's the end of this lesson. Good luck, and if you guys have questions, come to office hours.